Okay, so we have 2.1 integers and the number line. Remember that we talked about whole numbers and that whole numbers are 0 and the counting numbers 1, 2, 3, and 4. Well, integers are those whole numbers and then their opposites. So the opposite of 1 is -1. Opposite of 2, -2. So it goes on out indefinitely in that direction. Okay. An inequality. It's a math sentence that has the less than or greater than signs. That's all an inequality is. So then if we look at absolute value, which again, all these things are things you've heard before, but we're just reviewing. Absolute value is the distance away from 0. And the answer is always positive, or it could be 0. So, and we'll do a couple of problems here in a moment so you can see that in case you have not remembered or do not remember that. So now let's look at a couple of problems. I'm going to start with just deciding if these are negative numbers or positive numbers. So a halfback made a gain of 8 yards. Well, if he gained yardage, that would make it a positive number. So we'd be looking at positive 8 yards. Julia has a debt of $12. Well, she owes someone $12. So that would be a negative $12. Okay. Now let's look at a couple of problems. We're just going to do greater than, less than, looking at positive and negatives. Negatives work backwards from positives. So what usually would be higher ends up being lower. So just, you'll see what I mean here in a moment. So a positive number is always going to be greater than a negative number. Never any other idea there. So -4 is actually greater than -5. Okay. Now let's look at some absolute values. The absolute value of 17 is the distance from 0. And my answer will always be positive or 0. So 17 is 17 places from 0. -21 is 21 places from 0 in the negative direction. And then 0 is 0. All right, so now let's do some problems with the absolute value. So we have the absolute value of -5 plus the absolute value of 10. So the absolute value of -5 would be a positive 5. And the absolute value of positive 10, still going to be positive, so I would get 10. And 5 plus 10 would be 15. Let's try another one. Here's multiplication. We have 4. Absolute value of 4 would be 4. Absolute value of -3 would be 3. So we're looking at a positive 12. Okay. So here we have -4. That would be 4. Absolute value of 0 would be 0. Absolute value of 2 would be 2. Anything times 0 is going to be 0. If you saw that back here, you might have been able to go to the answer faster. All right, let's look at this one. So you have the absolute value of 8, which is 8. Absolute value of -3, which is 3, which you'll notice it says minus. Minus the absolute value of 5. Well, the minus is outside of the absolute value, so it's not affected by that. Only the 5 is affected. So we look at it like this. So 8 plus 3 minus 5 would be 6, because 8 plus 3 would be 11, minus 5 would be 6. All right, let's put some numbers in order. So we're looking at least to greatest. So again, they work backwards when they're negative. So I owe somebody $32 is going to be, or 32, -32 is going to be the smallest number in that group. The next smallest would be -26. Then we're looking for -24, -18, -16, and then we're left with negative 5. So when they're negative, it's going to look backwards from when it's positive. If these were all positive numbers, we'd be looking at a different group. All right, so let's go ahead and do one more problem, and it's just evaluating. So again, that's just solving. So I said x is negative 7. We have the absolute value of x plus 24. Now, I cannot take the absolute value of x because I do not know at this point. So when I'm looking at the problem like this, I don't know what x is. But when they tell me x is negative 7, I can use substitution, plug it in, and then I can solve my problem. Kind of treat it like parentheses. So the absolute value of negative 7 is 7 plus 24, so we're looking at 31. But you can't take the absolute value of x and get positive x because we don't know what x is. So we have to do the substituting before we actually start doing the problem.